Bits in a control logix processor can be referenced in a base tag, a member within a structure, or a bit within an element of an array. In a base tag, the bit is referenced by the tag name of a bool data type. An example might be a tag name of exhaust fan 1. In a structure, the bit is referenced by the tag name of the bool data type. An example is counter2.dn. In an array, the format for the bit address is array name element number dot tag or expression. An example of a numeric bit is motor1.5, and an example of a variable bit is motor1.index plus 3. In the SLC 500 series, discrete bits in file B3:X was used when it became necessary to create an imaginary output. To create a bit like this in the control logic system, simply create a new tag as base tag. The operation of the control logic simulator used in the CLX trainer is very simple. Just follow the prompts to put the simulator in either the run mode or the program mode. Operation of the program will normally be accomplished through the use of the I/O simulator panel located at the top right of the screen. Examine if closed. The examine if closed XIC instruction is an input instruction that examines or reads the status of a single bit at the bit location determined by the address. In this example, this bit location is referenced by the alias tag for the real discrete input. When an input or output module is configured, the base tags for that module are automatically created. An alias tag may refer to these base tags. A memory location, similar to a B3XX in an SLC 500, is referenced as a base tag. Output energize. The output energize OTE instruction is an output instruction that writes to the data table address specified on the instruction. The states of the instruction are true or false. Whether it is true or false depends on the logical continuity of the rung that the OTE instruction is located on. The example shown on this screen includes an XIC instruction on a single rung operating an OTE instruction. When the red, normally open, push button is pressed, a signal is sent to the input module at terminal 1. The controller will see a 1 in this status bit, then compare the state of the bit to the logic and set the output data for output 0 to true. The examine if open XIO instruction is an input instruction that examines a single bit at the bit location specified by the instruction's address. If the examined bit is 0, the instruction is logically true. If the examined bit is 1, then the instruction is logically false. In this situation, the XIC instruction is referenced to a normally closed push button. When the push button is not operated, a signal is sent to the input module at terminal 1. This makes the XIC instruction logically true. Pressing the button will interrupt the signal, causing the instruction to be logically false. The XIO instruction on this screen is referenced to a normally closed push button. When the push button is not operated, a signal is sent to the input module at terminal 1. This makes the XIO instruction logically false. Pressing the button will interrupt the signal, causing the instruction to be logically true. Output latch OTL and output unlatch OTU instructions are retentive output instructions. The operation of these instructions is identical to the operation of the OTL and OTU instructions in the SLC 500. Once the bit is set true, the rung containing the OTU instruction must become logically true to unlatch the bit or write a 0 in that address location. Even when the processor is switched to the program mode or experiences a fault, the bit will still be true. In the example shown here, when button SW1 is pressed, the bit is turned on. Even when SW1 is released, the bit will remain on. When SW2 is pressed, the bit is turned off. The purpose of the XIO instruction on each rung is to assure that the OTL and OTU instructions do not become true at the same time. The OTL and OTU instructions are normally used together with the same address. However, they may be used independently of each other. The SLC 500 timers and the control logix timers function in exactly the same manner. However, there are significant differences between the two. The time base of SLC 500 timers is selectable from 1.0 seconds and 0.01 seconds. The control logix timers have a fixed time base of 1 millisecond. The maximum preset and accumulated values of an SLC 500 is 32,767. The maximum preset and accumulated values of a control logix timer is 2,147,483,647. The timer address in an SLC 500 is a data table address or symbol. The timer address in a control logix controller is a predefined structure of the timer data type. The TON, or timer on delay instruction, is a non-retentive output type instruction. The TON instruction begins timing when it goes true. It continues to time until the preset and accumulated values are equal, or until it goes false. When the preset and accumulated values are equal, the timer's done bit, DN, will be set. The TOF instruction, or timer off delay, is a non-retentive output type instruction used to turn outputs on or off after a time delay. The TOF instruction starts timing when it goes false, and times until the accumulated value reaches the preset value or until it goes true. If the timer has timed out, that is, the preset and accumulated value are equal, the DN bit is reset. The timer resets when it goes true. The RTO instruction, or retentive timer on delay instruction, is a retentive output instruction used to turn outputs on or off after a time delay. The RTO timer starts timing when it goes true, and times until the accumulated value and preset value are equal, or it goes false. The RTO retains its accumulated value when it goes false. When the timer goes true again, it resumes timing from that accumulated value. When it times out, the DN bit is set. The timer is reset by the RES reset instruction. The CTU, or count-up instruction, is a retentive output type instruction used to turn outputs on or off after a specified number of transitions of the instruction. The CTU instruction will increment its accumulated value by 1 every time it is transitioned from false to true. The DN bit is set when the accumulated value is equal to or greater than the preset value. The maximum value that a control logix counter can count to is 2,147,483,647. The minimum value is negative 2,147,483,648. The CTD, or counter down instruction, is a retentive output type instruction. The CTD instruction decrements the accumulated value by 1 with every transition of the instruction. It is important to note that if the accumulated value is 0, as it will be after a reset, the value will decrement to a negative 1. The DN bit of the CTD instruction will be set when the accumulated value is equal to or greater than the preset value. As with the SLC 500, when the need for a reversible counter arises, you may program a CTU and CTD with the same tag. This will result in counters that will increment when the CTU instruction transitions and decrements when the CTD instruction transitions.